but still that it can sometimes get scary. I mean, the kind of developments that are being made. But uh, now, who is right? So I wouldn't answer that directly. I mean, what my focus has always been is, instead of looking so much into future, I mean, what's the how can I use this technology, and how can I build a career out of it? So because it's the right time, so let's get into that. So AI is not a new term, um, and AI is not a new field. The excuse me. So the developments in artificial intelligence started in 1950s, and the progress was so fast that in 1958 the prediction was that within 10 years a digital computer will be the world's chess champion, when computers were not popular also. By 65, people predicted that in 20 years machine will be able to do any work any man can do, a machine will be able to do. 1970 says people were so confident, they told like in 3 to 8 years we'll have a machine with the general intelligence of an average human being. So these are like really bold predictions, because the rapid progress, the pace of the progress was so high. So so predictions like this have always been there. So in 84, a famous professor told that AI will soon replace experts in law, medicine, finance, and many other professions. 84, and now we are in 2021, and still lawyers exist and doctors exist. So some of these predictions have not come true. Now, hype is always associated with AI and ML. So let's just take a quick look at a brief history of AI, so that we'll keep our focus in perspective. So work started in 1950s, and those were the golden years, 1956 to 74, when a lot of progress was made and these bold predictions were being thrown across. But then, as soon as people hit some reality checks, scaling up problems, or transferring those problems to real world problems, many of these failed, and that duration was called the first AI winter, when the progress all stopped. And then again 1980 to 87, again new work started, neural networks became a lot of these new algorithms came into picture, and again there was a lot of hype. So the 84 prediction was in this time, and then again funding dried, and no real progress was made. So 87 to 93 was again the second AI winter. And then 93 to 2011, the progress was made not under the name of artificial intelligence, but more under computer science and machine learning. So this is where all the machine learnings, neural networks, support vector machines, and all these new techniques, boosted techniques, all these techniques were developed, and these performed very well on structured data. And the work on unstructured data became popular after deep learning evolved, and 2011 to present, now we have seen an exponential increase in our capabilities with AI because of handling unstructured data with deep learning. So the progress has been there for a long time, and now if you see the again the predictions, if you see, are again like very hype focused. So we might need computer chips implanted in our brains to help us keep up with intelligent machines. So scary predictions. But like GPT-3, you might be aware, in the natural language processing, it can create some articles which can read articles and create articles which are really which can pass off as written by a human. So people are thinking it can take away their jobs. So once again, the predictions are going like into hype mode. So which can often result in a little confusion, like what is true and how much should we be worried, etc. So if we see the recent advances in AI have been mainly, largely in these fields: speech recognition, computer vision, language processing and understanding, and robotics. Uh, so these are the main things where deep learning has impacted, and recently a lot of work has happened and a lot of breakthroughs have happened. So in fact, in computer vision, computers have started to rival human accuracy. Uh, in language processing, engines can easily beat humans at answering general trivia questions. Deep learning has produced astounding results in competing with humans in all like games. Now the algorithms have taken over and they have surpassed humans by a wide margin now. So with this pace of progress, now how should what should we be? Should we be worried? It will take away all jobs. Should we be like? Are we confused? What to do? How to take care of this? How to what career to get into? Given that a lot of things are being automated. So a professor of artificial intelligence at IIT Hyderabad was saying, our job is to make our job redundant. So AI, the progress is happening in such a pace that a lot of programming itself will be redundant. Or should you be excited? So my suggestion and my experience has been that we should not be getting worried or confused. We should be thinking about how do I take advantage of AI and ML technologies? How do I build a career around it? So now career. So building a career around it. Now it is very confusing nowadays. If you see, there are articles claiming this and that. It's like the progress AI and ML is making in each every field is so vast that it's difficult to catch up with all the progress itself. So in NLP, daily like new articles come up, new algorithms are proposed which perform better than earlier. In voice, same thing happens in like speech recognition, video analytics, deep fakes. When computers are creating such huge strides that it's like, easy to get confused. So right now we should make a distinction right here that do you want to get into the theoretical aspect of this AI and ML, or should you get into applied? So that choice should be clear now. So if you decide to get into theoretical, then you will study a lot more in the AI and ML techniques, the math behind it, the science behind it, the techniques, and how to make these improvements in the algorithms. So if your focus is that, then you should work towards that. You'll need a lot of math, science background, engineering, software, a lot of knowledge around that, and then you can work on directly in AI and ML. The other way you can mold your career is about the applied, like how to apply these improvements which are happening, these new techniques which are coming up to achieve some results. Now so I have made a choice to go to the applied side of AI and ML. So my focus of the career has been to how to apply AI, ML, and other modeling techniques to get more deeper business insights, better business results. So if you choose any one of them and you make a focused effort towards building your career around it, you will. This is a great time to do that. So this talk is only about the applied side of it, not the theoretical side of it. So just to establish a common baseline. So what is machine learning? It is a branch of artificial intelligence. So artificial intelligence we saw started in 1950s, and a lot of progress at that time was rule based, and like trying to find out, like trying to do some brute force new features, and then use all the combinations of calculations, and then a machine can do a lot more of these calculations and come up with something which is surprising and intuitive and very helpful. So even in 1950s, an AI algorithm was able to recreate the astronomy, like some of the laws. I don't remember which one. I think Copernicus. So one of those laws, Kepler's law, I think, or one of those laws. So, so machine learning later on was the focus area where AI also became popular because of machine learning, where the instead of moving from like rule based into algorithms which learn from data and improve themselves. So now there are different definitions of machine learning. So like one of them is that study that gives computers the ability to learn without being explicitly programmed. So this was in 1959, and recently algorithms that automatically discern patterns in data use the uncovered patterns to predict future data or other outcomes of interest. So finding patterns in data, so that's the core of machine learning. And again, just to establish the baseline, so very high level view of machine learning. What do we do in machine learning is that we want to predict, or we want to get some output, and we have some inputs which are the features, and we are trying to come up with the best prediction function and the weights to minimize the errors in this prediction. So that's the very high level view of machine learning, and we'll take this approach. And so this is a very high level, I would say, like a philosophical level of abstraction to machine learning. So this is what we do in machine learning. And now, like, how do we use this to solve business problems? So let's get into that. So a real world problem may look like autonomous cars. Like how do you make self-driving cars? Now at first sight it looks like a very complex problem. There are just too many things a driver does when driving. I mean, just taking care of any and every obstacle, like how the cars will behave, someone will jump into the lane or not. What are the signals, what are the signs on the road, speed limits, when will the exit come, how the other cars around it are behaving. Very complex. And then like how much to turn, when to change lanes, when to slow down, what speed to go on. So a lot of different things are happening here. But how do we make this into an AI or an ML problem? So a very high level abstraction would be like, what are we trying to, what is the output here? So if we abstract it at a very high level, there are only two outputs that the car needs to decide when doing this. One is, what angle should the steering tilt? So this is a numeric output, like should it continue like straight 0 degrees or 5 degrees to left, 5 degrees to right, so -5 +5. So steering how much to rotate. So that is one decision. And the other decision is, at what speed should it be running? So does it need to, so the acceleration level, is it plus or is it minus? So minus will mean braking and plus will mean acceleration. So this, now given all these features, like all the buildings and whatever is there on the cars, if somehow we can handle that, our output is very simple. Only two things we need to output: this change in steering and the change in acceleration. So once we do that, then it becomes easier to convert it into a machine learning problem. So given that these are the outputs we want and these are the features, now how do we get into solving this? So that's the approach I recommend. So this is the framework. When we have a machine learning, when we have a business problem, what we do is we take raw data, we extract as many features as possible, and then we run an algorithm to create some output. So this is a very high level machine learning framework. How do we apply it to different scenarios? So for example, in spam detection, what do we do is we have raw data, which will be the email text. Now, email text will have from to what is the message, when it was sent, etc. So out of this, we can extract some features like where is the person sending that domain. So you will see in subject, your Amazon account is on hold, but the domain is not from Amazon. It's from someone, like some junk domain. So that's an important feature where if it's not Amazon, maybe we can mark it as a spam. So we extract that feature. Then we use word counts of different uh, known words which are used in spam emails. So free and offer and prince and now Nigeria and all those words, inheritance and all those things. So these things are the features, and then once you extract the features, you apply some algorithm to decide the output. So in this case, naive Bayes will also give a very good output. Then the output is whether this message is spam or not spam, or a probability of it being a spam. So that's one. So that's how we apply machine learning to solve a problem, given problem. So now, because we use it in different problems, so let's just see. So for example, sentiment analysis. We have to find out the sentiment of a tweet. How do we solve it using machine learning? We can again get raw data, get the details about the tweet, who sent it, how many connections they have, what were the reactions of the tweet, and then the words in the tweet. Are they like known to be like positive, very happy, excited, works great? I mean, something like that. So those are all positive ones versus it was a letdown, disappointed. So those are negative words. So find out which are the kind of words present in this tweet, and then run some algorithm to create output, whether this is a positive sentiment or a negative sentiment or a score related to that sentiment. Similarly, in medical diagnosis, we see given what kind of raw data we can have, so we can get the patient's history, their hereditary characteristics, whether the parents had any disease history, all those past data, the current measurements, BP, weight, etc. We create all those features, we add all those features, we look at one of these algorithms, and then we run the output. Whether it's a cancer, no cancer, whether it's a TB or no TB, etc. So product recommendation, again, given past product purchase history, we collect data on all of these, and given the historical purchase data, like after purchasing these similar set of products, what does the user purchase next? So if we run our, like, we create features related to that, run our algorithm, and then create output. So this is the general framework we use to solve a business problem, convert it into a ML problem. So these are some of the common things you will learn in any machine learning courses. So you would probably already be familiar with this. So now let's get into some of the real projects I have either like worked firsthand or experienced in the companies I have worked so far. So at IIM Bangalore, I worked with a professor on consulting company where we did consulting for a telecom company, and they were working with their prepaid customers, and then trying to figure out who should we send these. We send these targeted offers. If you recharge within the next 3 days, you will get 10 rupees off. If you recharge with minimum of 50 rupees, something like that. So they create different these offers. Now, who should we send these offers to? When should we send them? And how much should the offer amount be? So this was done in like 2014 and 15. So when machine learning, I mean, this was a typical case. Even now, this is a very typical machine learning case. You would already be familiar with how to do this. So we apply the same framework. We we first get the features. So features will be like whatever features we can get on the user. These companies for prepaid, they don't have many features around the user demographics. Only the age may be there, and then location. Then the usage. Based on usage, we create many different features. How frequently does the customer make STD calls? Does he make ISD calls? Does he or she make calls from the same area where they have taken the SIM from? Do they do a lot of roaming calls? A lot of these features can be created based on past data, and then once we do that, then we run our ML algorithm. So different types of ML algorithms are available to do this different types of to answers. So who should we select? So now this can be done broken into in the past data who have actually used or who have actually taken the offer when they were sent, and can we find a pattern which separate the people who have actually taken the offer versus people who have not taken the offer. So the machine learning can find out web patterns and figure out what is common among those people who have taken the offers, what is common among those people who have not taken the offers, and then try to predict who will take the offer in the future. When should we send them? We are trying to predict the time, like how many days in how many days should we send. So there are again different types of models. So we use survival models to do this. Now that's not a common machine learning algorithm, but eventually you will learn other algorithms as well, which are not directly machine learning. One of the most interesting projects I had seen was in my previous company, where a client was a B2B product company. And they came with the question of, so I was working with Decision Point Analytics. They are a consulting firm. They solve a lot of these problems for many FMCG and large Fortune 500 companies. So one of the B2B clients told, can you help me improve my sales representatives' effectiveness? Or I have launched a new product, but the dealers are not willing to try it. Or I know that this dealer should buy more, but they are not willing to they are not willing to consider our opinion. So they take their decision based on our. So can you help? Can machine learning help in this? So as looking at it, it looks very difficult. How can we apply machine learning to this? Like how can we use machine learning to improve sales representatives' effectiveness? So that's all dependent on the sales representative, how they convince the clients. So how can ML be used? So what the data scientists there did was, so to make this into a business problem, this problem into a machine learning problem, what we need to do is understand what is happening in the background here. So now these representatives go to different dealers, and these dealers have their own viewpoints. So they know that, okay, based on past upcoming season, next 2-3 months, I expect this kind of demand. Based on how many competitors have opened, I can see some demand. So they have some idea, and based on that limited viewpoint, they make their decisions. While the manufacturer has a view of the whole market, like they know exactly how much the demand will be. They have the sophisticated data and the tools to make accurate forecasts in the area. But the dealers, they don't trust very easily. So what can we do? How can manufacturer convince the dealers to buy a new product or a different quantity of an existing product? So this is where Decision Point created a product for them, which is called Fable. So which helps the representatives with selling stories. Now these stories are basically data-based arguments. So what is happening here is that how is the dealer making the decision to buy or not buy? So the dealer is thinking, okay, what will be my expected sales? What will be my margins if I buy this much? Will I be left with too much of stock? How many competitors are there? What is happening in neighborhood stores? Are they running some promotions in nearby stores? So dealer has to think about all this, and that's why they are making a particular decision. So now to convince them, what we need is so now this is again a y is equal to fx kind of a problem. So this is the machine learning framework. So dealers decision making is also very similar. It's like although the function is not a defined function, it's based on their intuition. So they are also taking some inputs into mind and then making some decisions based on that. So once we know that, then we can come up with the machine learning algorithm, because the manufacturer has a better data on this, more data on this. So what this product does is, now we can take a look at all these dealers' past history, what the sales have been in that region, how the sales of competitors have happened. So now with that kind of a detailed data, we can come up with some really convincing stories for the clients, for the dealers, that okay, if you don't take this in this area, in your area, these people have like so many people, so 20% of or say 80% of dealers in your area have stocked up on this product, and it's expected to sell. Now that kind of argument now based on data will convince the dealer, okay, yeah, so if others are doing, maybe I should be also doing it, or I'll be missing out. So this product is called Fable. You can check it out. So this was a very interesting case where a very tough business problem was solved using machine learning. So we use AI and ML at redBus also to solve a lot of problems where it's not possible to work at a human scale. So dynamic pricing is one of the key projects I'm working on right now. So based on demand, like how should we price the bus ticket? So based on if there are holidays, the people are willing to pay more, and they are okay to pay higher prices, and the BOs can charge higher prices. But then also when there is off season, so when there is no demand, if we keep a fixed pricing, people don't want to pay 1,000 rupees when there is like if they are willing to pay 1,500 during festivals, they are not willing to pay 1,000 rupees when there is no demand. Like, or if they are traveling on a Wednesday, they'll think, why should we pay 1,000 rupees? So dynamic pricing enables us to offer lower prices during low demand times, so that we can price higher and then balance the profits. So a lot of complex calculations happen, but again the decisions are very similar. Can be reduced to what should be the prices. Now the inputs can be many, like the seasonal factors and the competitive actions. So a lot of inputs, one output, and then a lot of machine learning behind it. So redBus people, when initial days, there was some abuse of the ratings facilities. So BOs, I think some customers or some of these digital marketing agencies, they do some black hat activities. They do some unethical practices, like creating fraud ratings. I mean, they'll take some money from someone and then they'll put wrong ratings to bring down a competitor. So a lot of such cases were happening. So we used a text mining algorithm to solve that, to automatically detect a possible fraud, and then either handle it automatically if the algorithm is very confident, or flag it for manual check. Customer churn modeling. So based on a lot of past history of the customer, when do we expect the customer to churn, and can we do something about it? Can we improve? Can we reduce the customer churn? Dynamic discounting. So we cannot give discount to everyone because that will cause a loss. So who is most likely to get converted if you offer a discounting? We use AI and ML for marketing mix modeling, so which means that our marketing department runs a lot of campaigns, invests in a lot of money in different campaigns. Now, which of these campaigns is working well, which is not working well? So doing that is called marketing mix modeling. Review moderation. So So other than ratings, even reviews are sometimes fake reviews created by some third parties, which we are able to handle using machine learning and text mining. Image recognition. So, for example, we are like trying new things all the time. So, for example, if a customer clicks a location that this is my boarding point, can we automatically say that this is the right boarding point or not? So, these are some of the pilot projects we're doing. Uh, so, a lot of projects are happening on AI and ML at redBus. Uh, so more or less, yeah, this is what I wanted to cover. What I want to take from here is that if you decide to go into the applied ML field, uh, you should always think of how to convert a given business problem into an AI ML problem, and we use this framework to solve to do that, to convert it. So what are all the features? What are the things which are uh, correlated with the outcome variable? And then once we collect all those features, what all could be related to the output we are interested in? Then once we do that, then what is the output we are looking at? How will our algorithm? How do we know our algorithm is successful or not after we do this project? How do we know whether it's successful or not? So to do that, we need to define the measures beforehand. What are the KPIs? So once we do that, once we define these inputs and outputs, then trying the various ML algorithms is the easier part. The tougher part is the handling all the data, collecting all the data, and handling all the errors in data and data cleaning. So modeling takes only the smallest effort. It's more of working with the data, collecting the data, and working with the data, and so those are the challenges. So that's all I wanted to cover. So one thing related to the hype, one thing very interesting is Moravec's paradox, which is it is relatively easy to teach AI to do things human think of as hard, and hard to teach them things human think of easy. So yeah, with this I close and open to any questions and answers.
If you have any questions, write it in the Teams chat, or if you're watching the YouTube stream, write it there in the YouTube comments, or if neither, you can raise your hands. Like if you can't see the chat, you can raise your hand. We'll give you the permission to unmute and then you can ask. Manish Kumar, you should be able to unmute now. Please go ahead with your question.
Sir, can I make these redBus application using Python codes?
Yes. So do you mean like the projects we are doing within redBus? You're talking about that, or?
Sir, basically, I want to say that I am a fresher and I know only Python language. So I am asking that can I make it in Python language?
Yes, definitely. So Python is the language of choice now for machine learning. So at redBus, we use a lot of Python for our data science work. A few of the applications where it's very like real time, where we are putting it to the real time production environment where the user are interacting with it. Sometimes we convert it to Java, which our engineering team does, but the data scientists, they work in Python only. So Python
Sir,
is
is it possible?
something you should
Sir,
pick up and become strong in.
sir, is it possible to build all the project in Python language?
Yes, definitely.
Okay, sir. Thank you.
Build as in nowadays there are a lot of algorithms already coming coded as libraries, so we can use those libraries. So a lot of data cleaning and processing will be done in Python, Pandas, NumPy. Once that, then the scikit-learn and all for the machine learning. But everything happens in Python.
Okay, sir. Thank you.
Now moving on to next question by Nalluri Khyati. I'm giving you the permission to unmute. You should be able to unmute now. Please go ahead with your question.
Explain. Hello, sir.
Hi.
Sir, could you please explain the expected output for the given problem given?
Okay. So you're talking about the hackathon.
Yes, sir.
Okay. Yeah. So hackathon related questions we'll take at the end. So some people have registered for the webinar who are not participating in hackathon. So if they have questions related to the webinar, then we can answer that first, and then I'll answer your question about the hackathon.
Okay, sir.
Okay, so as stated, the question specific to hackathons can be taken afterwards. So if there are questions specific to webinar, please go ahead with those. We'll only be able to take one or two questions here from the hands which are raised, and after that there were a few questions which we received in the forms and we feel that they should be answered. So we'll move ahead with that before moving on to the problem. Now I'm taking the next doubt from Ashish Tikariha. I hope I pronounced it correctly.
What prerequisites are required for theoretical side?
So for theoretical side, you will be working with the algorithms and the back end of the algorithm. So you're trying to improve it. In application side, you are trying to run different algorithms. If you choose one, so you have some hyperparameters which you can tune. But in the theoretical side, you are coming up with the algorithms or making more like modifications to the algorithms. So, for example, linear regression. We know that we minimize the error to get the best fit line. Now that is modified to solve some specific problem that there are too many variables, and we are trying to reduce the number of variables also. So how do we do that? So now there is an additional modification to the error function, which is, for example, a regularization. So instead of the normal error function, we try to minimize the error plus the sum of coefficients. So now that forces the sum of the coefficients to become 0. So those are like some of the modifications. So that's how ridge regression came, lasso regression came, and elastic net regression came. So when you're working on that, then you should understand these base algorithms very well, and you will. So you'll have to have an understanding of the statistics behind it, the math behind it, linear algebra, and also how to code it. Because when you are trying to come up with improvements to an algorithm, you have to code the algorithm, and then because it's not available, you are proposing something, you are testing something new. So these are done by people who are like into computer science. and their focus is also in computer science and the algorithm design.
Okay, so now we'll be moving on with some of the questions we received in the form we circulated like around this the time of announcement of the webinar. One of the questions is the occupation of a data scientist as vulnerable as the other fields, as Sir discussed himself, like replacement by AI, replacement by other mechanized methods? And what are some real life problems and challenges which are faced by a data analyst?
Okay. So one, so career of data scientist. So the number of data scientists currently needed is growing. So we are still looking for more data scientists, and the problem with data science job scenario right now is that there are these training institutes which offer which try to promise some things which are not realistic. So you don't need to learn any math, no coding, just come and we'll teach you everything. And so that creates an illusion that, okay, just by running this ML algorithms in Python, sklearn a few lines of code, you'll become a data scientist. So if you have invested in such training, so that's a good start. But if you end your learning journey there and then you think that you got a job of a data scientist, you don't need to learn anymore, then your job will be at risk. So to continue to be competitive, you'll need to be really good at something. So identify something as your strength and then be really good at something. So it could be the technical side of it. So machine learning algorithm is not it's not a typical like a one-time project. So we'll also need to implement it in production. So if you become really good at productionizing that, for example, there is a lot of scope for machine learning engineers. If you become really good at solving, like converting all of these business problems into a machine learning problem, so then you have a great career ahead in consulting. So where you solve all these, take all these business problems and then you convert it to machine learning problems and then pass on to some other people. And then, so you can also venture into consulting. If you are into data science itself and if you keep yourself updated, reading and trying to understand deeper behind what is happening in the algorithms, why you choose some algorithms over others. If you keep on learning on all those aspects, then you will stay competitive. But don't go by the promises made in these advertisements that you don't need to know anything. I mean, we'll just teach you everything and you'll be a data scientist. So that's a good start, but then to be competitive, you'll need to continuously learn and focus on one of these areas and build upon it.
That's a really insightful answer. One last question in the continuation is, what are some of the applications of machine learning in mining engineering field?
Okay. So once again, we come back to our framework. So we have some output we want to predict or to alter, and then we have some variables which are correlated to that. And so how do we map these? So what are the discussions in, like, what are the areas in mining engineering where we can use these ML algorithms? So I am not very like not an expert in mining at all. So my focus was mechanical, and even after joining job, I shifted into software. So not much insights into mechanical as well. But in mining again, depending on so in mining, it could be like finding the sites which are have the possibility of getting more, like having more deposits underground. So how do we do that? So when you then you need to like come up with some of these decisions which can, where ML can help. So anywhere where a decision is being made based on some variables, you can probably use ML. So how do we find out? So you'll have to understand the current decision making process. How do we find out where to go deeper into extraction? Which are the possible areas for extraction? So we'll probably be doing some soil testing, some pilot digging, and then analyzing all those variables. Whatever comes out, analyzing that. So as soon as we know that what are the decision variables, what is the outcome, we can create machine learning algorithm to solve that problem. So specifically, I don't know, I don't keep track of mining engineering, so I can't give a more detailed answer, but this is a way to approach.
Okay, so that as well was like that as well was a very insightful answer. Now moving on to the problem statement part for the hackathon. If you can go ahead with explaining the same.
Okay. So yeah, so this is a problem we are trying to solve at redBus. So redBus is a platform where all these bus operators can list their bus services, and they can sell their tickets online. So anyone, so we connect all the users with all these bus operators. So we are a platform. So now these bus operators are of different capacities. So some of them are very small, some of them are large bus operators running hundreds of services, different routes. So some of these operators, they don't know how to price their tickets correctly. So sometimes they choose to just follow a competitor. Some of them are very sophisticated. They employ pricing people who will do this pricing. So whenever a new route opens up, or when we are trying to look deeper into one route, we often need to understand the market dynamics, which is like who are the players who are pricing here independently, who are the players who are trying to follow some competitors. So this is a problem we are trying to solve. So given the pricing history, like how they have priced over last few days, last few months, how do we find out who is following whom and who are following, like who are pricing independently, etc. So that's the high level problem statement. So the data given is the history of prices for a single route. There are many bus operators and there are many bus services. So a bus service can be, so the same operator could have two different bus services. So one departs at 8:15, one departs at 9:15, etc. So these are listed as different buses, and these people are pricing. All of them are pricing the available seats. So given the pricing history, how do we find out the market dynamics? So who is follower, who is the leader? So this is what we want to find out, and this is where we need your help in finding. So given the price history, how do we find out? So what you need to do is now come up with some method. So now there can be many methods. I'll not take names because that will force your thinking into one direction. I don't want to do that. I want to keep it open. We want new perspectives. So you can look at what these bus operators must be thinking when pricing, and can you test some of those hypotheses in the data and then like come up with who is leading, who is the price leader, who is the price follower. Now some of these, so ideally, I mean, the algorithm will score all of them. So for each of them, they will try to identify a nearest the follower and a nearest person who this person might be following, and score them. So there must be some score. So when you're trying to see one one service. Now, in reality, they may be following one major competitor, but our algorithm will not know exactly uh, which one it is, right? So it will score that, okay, this is most likely the algorithm, the bus service, this one is copying. So then it will assign some scores at 0.85 confidence that this is the person this is following, with 0.7 confidence that this person, like this is the bus service this service is following. So we need only the closest match if the person is following, like which one the person is following and which one the person is leading. So basically, just so now if you think that this particular bus service is not following any other, it's just doing pricing independently, then automatically the scores for all these, both of these will be low. So the low confidence scores we can filter out, saying that, okay, yeah, these are independent price setters. So your submissions expected output has three components. So one is a one-page summary of your approach. What is the approach you've chosen? You can justify if you want why you've chosen that, but one-page summary, only one page. And your output, so with all the services, and to identify who this person is likely following and who is the bus service which is likely following this service. So if this is the leader, then who is the closest follower? Scores for that, so and the code. So these three outputs are expected.
If anyone has any question regarding the hackathon, please mention in the chat, or like as previously, raise your hand. You'll be given the permission to unmute. Manish Kumar, you still have your hand raised. I'm unmuting Chakrabarti Ankit. You have been given the permission to unmute. Ankit, can you speak up?
Hello. Good evening, sir.
Good evening.
Yeah, I just wanted to know your perspective of the correlation that work in this segment has with getting recognition by the ACM authorities or the IEEE authorities. So, what I am actually asking is that is work here correlated with such brilliance that we can discover that it can actually stand the test of time, rather than just doing something that can perhaps be better priced with time. So, is there a scope of having a very breakthrough algorithm that can get recognized by IEEE or ACM authorities, that can make us make our efforts worth, and make sure that it stands the test of time? So, this is my question.
Okay. Yes. Definitely. This is an open area in research. So there is no a clear-cut method which will just solve this problem. So if you can come up with an approach which does well, perform well, there is definitely scope for proposing it in conferences. So we can look at it. If we can support on that, I don't know, but the method definitely can be used for research and publication as well.
Oh, thank you so much.
Moving ahead, like initially I'll request all the participants to ask their queries regarding the hackathon first. We can take up the general queries if we have the time remaining. So if you wish to ask a hackathon related queries, please raise your hand, otherwise put it down for a bit. Now I'll give Manchala Nitin Teja the permission to unmute.
Good evening, sir.
Good evening.
Yes, sir, I had a question in the input. So, can you once specify what does the service date column mean? I mean, does it
So
mean?
service date, yeah,
Yes, sir.
service date is a day of journey for that service.
Yes, sir.
So
So my question is, it is given as, for example, for the first bus, it is given as 15:07, and the time is given as 12 a.m. But sir, if we
yeah, so
from
timing is not given. Like all the date of journeys are only the date of journeys are given.
yes, sir. But like in the column after the date, we have 00 and again 00. So I thought that was the time at which the bus was leaving.
Okay. No. No. Actually, it's only the date.
Okay, sir. So we just have to consider we just have to take the day
I don't
into
think we
account,
have
right?
given the timing date. Yes.
Okay, sir. Yes, sir. Thank you, sir.
Moving ahead with the questions, I'll now give permission to Ankan Biswas to unmute. Ankan, please go ahead with the question. Ankan? I feel there are some audio issues with Ankan. For once we should maybe move ahead with some other doubt. Now I'll unmute Sridhar to ask his doubt. Sridhar, you can unmute now.
Hello.
Yes.
Are you able to listen to me?
Yes.
Yeah, so I have a doubt that in the output, you are asking for follows. If it's an independent price, independent or the leader pricer, so what do you expect here? The self name or one or something like that?
No. So if so we're so it's a generic like a leader like follower and leader field. So if this particular BO is not following anyone, so either it will be blank or it will be the like whoever is the lowest, whoever is the closest. This BO might be following, but the confidence score will be really low for that.
Okay.
So lower confidence scores will indicate that this is not really following.
Okay. So the thing is, we need to figure out like like the scores which will indicate like if it's a follower, the confidence score in the first column or the for the follows will be low, and if it's someone to be followed by, then the confidence score would be high. Like if people are following these kind of bus, then the
Yes.
okay.
Yes.
And that, but what should appear in this follows and is followed by columns?
So basically, your algorithm will compare for each bus service. So we are taking, say, one example, one row. So for this particular bus service, who this particular bus service is following, most likely following. So now your algorithm will rank all of them and report only the highest one. So if it is most likely following this particular other service, service A, you'll report A and the confidence score will be 0.95. I mean, your algorithm may rank B, C, D, etc., but lower confidence score. So you will report only one of them, the highest score. Okay, so if this service is following service A, you will report service A and then the confidence score. Now, if this particular service is being followed by some other BO, so now that is, so you will report that score also.
Okay. So basically, the highest of
So
both of
highest
the
score.
things
So yeah,
should be named
yes.
with the
So
name of
this,
follow.
yes. So this particular BO may be followed by 2 or 3 people, but you will report the highest scored one.
Okay, sir. Thanks.
Now moving ahead with the questions, I'll now give permission to SM Tawhidul Islam Tanmay to speak. Tanmay, you've been given permission to unmute. Please go ahead with your question. Tanmay, are you there? Okay, I feel Tanmay doesn't have the question, or his question was being answered. Let's go ahead with Ajoshi Krishna Sai. Krishna, you have been given permission. Yeah.
Yeah, good evening.
Good evening. What is the expected outcome, sir? Please once again explain me.
So expected outcome is like for each BO, for each service, bus service. So there's a unique list of bus services. So for each bus service, we want you to identify who is the closest. So your algorithm will match and calculate scores for all of these, right? So what is the probability that this service is following this service? What is the probability that this service is following other like service A, service B, service C? So some probability score will be calculated, right? So you'll report the highest probability one in the one row which is given. So if we are talking about one particular service and your algorithm decides that it follows service C with the highest probability of 0.95, you'll report service C and 0.95 there.
Thank you, sir. Thank you.
Yeah.
Moving ahead with doubts, I'll now unmute Rishi Suvada to ask his doubt.
Yeah, so I just want to ask how the redBus policy actually works. Like if there is any halts in between the route, so can we actually book a bus after it has left its starting point and like we want to board somewhere else in the between? How does that work?
Okay, that is related to a redBus policy, not hackathon, but yes, we have enabled it. You can book even after departure.
No, I just want to ask if the data is given just for a single route, or is it for different
data is for single route.
Okay, that makes sense. Yeah.
Before moving on with other questions, as we are like running out of time, I'll ask sir how many more questions will we be able to take?
I have time. I mean, we can take 5-10 minutes more.
Okay, so we have about 5 to 10 minutes more. I think we'll be able to take 2 to 3 questions in the time. Now I'll unmute Avish Kumar. Please go ahead with the question. Avish, I believe has his doubt sorted. Moving on, I'll now unmute Shubhodeep Devnath. Shubhodeep, please go ahead with your doubt.
Hello, sir.
Hello.
My question is from Hackathon. There are two type of input field, the seat type 1 fare and seat type 2 fare. And in the seat type 1 fare, there are multiple values. Some values on the left of the column, some values in the right of the column. In seat type 2 fare, there are only some of the cases there are values, and some of the cases there are written 0. So what does this meaning? Could you please explain?
Yeah, so that is one of the challenges when working with real world data. So what happens is now the available seats. So the prices will be displayed only for the available seats. So and these bus operators, they define their own categories. So in general, there are two seat types, but within a seat type also, if the seat is in front or back, window or not window, sometimes the service operator will decide that there are three more categories of seats, so I'll price three different ways. So single seat, I'll price in one way, front single in one way, back single in another way. So there may be three prices, four prices, depending on how the operator has categorized those remaining seats. And as soon as that particular category is all sold out, they will stop reporting the prices for that, and it will be the price vector will show values only for the remaining type of seats. So zeros are an anomaly. Sometimes it's because the seat have been sold out, but still something may have happened in that time, so that's why zeros are being reported. But that is a challenge you'll have to handle when working with any real world data. So we didn't clean it up for you. I mean, you'll have to do the cleaning yourself.
Moving ahead with the questions, I'll now take the question of Priyanka Priyadarshini. Please go ahead with the question.
Oh, sir.
Yes.
Sir, actually, my doubt is that we have been provided with two CSV files. One is the sample output, the other one is the pricing. So what we need to do is that we'll be trying to find the pattern from the data which is given in the pricing data set, and from that in the output sample only the bus name bus column is filled, I guess. So
Yes.
the rest of the columns we need to fill it, and
Yes.
that will be only given in the submission.
Yes. So in the submission, yeah, you will give the output CSV along with your code and the one-page summary.
So the sample output CSV, which
Yes.
you have provided to us,
Yes.
will
That
be
will be
filling
filled.
the
Yes.
okay. We'll be filling the rest of the columns, and then we'll be submitting that.
Yes.
Okay, sir. Yes. Thank you, sir.
Moving on with the questions, I'll now take the doubt of Neeraj Thorat. Neeraj, you can unmute now.
In the input data, so there are type 1 seed and type 2 seed. I didn't get the difference between the two. Why is there is categorization of seeds?
So this is how the bus industry works. I mean, so there are two types of seats. So that's the standard across all services. But within each type of seat also there could be categorization done by the operator.
Okay.
Okay. Moving on with the questions, I'll now ask Sridhar to go ahead with his question. Sridhar. Okay.
Hello. Yeah, actually, yes. I have given a chance, but I have one more doubt. Can I go ahead?
Okay. Yeah.
Yeah. Thanks a lot. So I had a question from the input space. Here we are actually given, like you said, 0 might be an anomaly. So you mean to say that there might be a price when there is a blank space, there might not be that type 2 fare for that service, and when there is 0, there might be a chance that the seat was filled and by some way, zero has appeared there because of the filling of the seats.
Yeah, yeah.
Okay.
So it's still like no available seat to sell.
But that category is present in that bus.
Yes, yes, yes. So yeah, zero is an anomaly.
Fine, thank you.
I'll request the participants, if your doubt has been answered and you don't have any more doubts, please lower your hands. Now I'll ask Lakshman Nayak. Just a second. I'll ask Lakshman Nayak to go ahead with his doubt.
Hello, sir. Good afternoon. Sir, in seat fare type 1, for each particular bus at one particular recorded time, there are two values, and in some rows there are 3 values. So what does that represent actually?
Yeah, so at any point in time, this will be the prices of different subcategories within that seat type. So so the service operator may have decided that I'll price 4 different categories. One will be the single seat in front, one will be single seat in back, one will be double seat in front, double seat in back. So 4 different categories. Now single seats in front may be like sold immediately. So now the price vector which started with 4 may have only 3 after that point in time. Now the single seats in the back may also get sold, and only the double seats in front and back are available. So now the price vector will have 2 more values only remaining. So that's how the number of prices will keep on varying.
Yes, sir. Thank you.
Now I'll unmute Dornala Venkata to ask his question.
Excuse me, sir. So in the input data for the bus column, is the row repeated every time when there is a price update for the operator?
Yeah, so there could be a row each time the price updates, or there could be a row just based on time events, like every hourly it might capture the price or something like that.
Okay,
so
sir.
It could be time based capture or a price update capture because of price update.
Okay, sir. And the second doubt is, are all the bus routes, like all the given buses going to the same destination and from the same source?
Yes, yes.
Okay, sir. Thank you, sir. That's my doubt.
Now moving forward, I'll unmute Machrala Nitin Teja.
Yes, sir. When we are saying an operator is following another operator, we're not expecting him to just replicate the prices, right? We're actually expecting him to use some very complex functions where the input is the price of his the person is following.
Yeah, yeah. So it will not be exactly replica. They may be altering it a little bit, keeping some distance in prices, even varying that distance based on the prices. We don't know, but yeah. So it will be. So that's why the output will like calculate some probabilities or the confidence score. Like it will not be a perfect match, definitely.
Yes, sir. But we can like measure if this person is decreasing the price, and if another person has decreased the price at the same time, then we can see that this person might be following this person. We can use something like that.
You can use all that logic. Yes.
Okay. Thank you, sir. Thanks.
There's one last doubt remaining, and the person who has raised the hand has a numeral as their name. So I'm unmuting 190110 and so on. Please go ahead with your doubt.
Yes, hello. The sound is coming?
Yes.
Yes, sir. I have multiple doubts. from the data set you given. First of all, in you already tell, but I have dialed a seed fair type 1. There some has 2 values and some have 4 values. So did it doesn't it really means in a data set, like it will affect our machine learning algorithm, like we have to fit data into the model. So
Yes, yes. So I explained to you the business logic behind it, right? So why sometimes there are 4 prices, sometimes 3, sometimes 2. So these are the subcategories of seat within that seat type. Seat type 1, the service operator may have defined different subcategories. So single seat in front, single seat in back, double seat in front, double seat in back.
and my yes sir, I got it little bit. And second doubt is from output data set. Here is a column called bus and every value is different. So the value is a bus ID.
Yeah, yeah. It is the bus ID from the pricing data only.
And this all bus ID are different, means unique in data set.
Yeah, yeah. So it's just a unique list of all the bus IDs from that input data set.
Because I have seen like in model, like there is a like date type of a column and name type of column, ID type of column. These are actually are removed from a model while data pre-processing. So I was just thinking it will really help us because it is all unique value and just IDs. I know it is a bus ID, but how we will
But see, we can't do anything to that, right? It will be some particular bus service. So it could be SRS Travels. So how does it matter if we give the actual name versus the ID? So anyway, you will not be able to use it.
And at a given data set, input data set, recorded at name of column in which there is a time also given. If it is right, time is given.
Yeah, yeah. So that is the timestamp when the prices were captured.
Okay, so it is important for us to take care of it.
That you can decide in your solution how whether if you neglect or if you include that, does it help or not?
Okay, sir. And I was thinking like we should get some more information about this problem, because I am thinking like it is a little bit less information is given.
Yes. Information is less as
I'm
in.
not talking about records numbers, but I am talking about the column value size. We should get some more columns so that we can differentiate and make a relation between the columns.
Yeah, but this is where I mean you can create some features, and you can also don't try to just fit in a machine learning algorithm on the given data as it is. Try to think.
We are not directly fitting.
Yes, yes, yes. So try to think what is happening here and how can you find out who is a follower, who is a leader, and then based on that you can create some features.
And the second thing is the operator is that operates the bus for two, right?
Yes.
And what does it mean follows and is followed by?
So that is the whole problem statement, right? So
yes, but because we also have to
whether
know why this column is here, means follows.
So that is the output, right? So you're trying to find out if they follow the pricing of a competitor or not. So if they are trying to if they are if they are just merely copying a competitor's price, then you will identify that as like following that particular competitor.
Yes, that is for follows column, and is followed by.
So is followed by is actually, it might end up being redundant, but right now it is that similar thing that this particular service, if anyone else is following, who is the most likely one to be following this service. So it will not really be redundant, but yeah. So basically, for every service you are doing, which is the most likely service this particular guy is following, and which is the most likely service which is following this particular guy.
Okay. Okay, sir.
Yeah.
I am little bit satisfied. And the second thing I was talking about, I am just saying to the host, the number is 10190 is my school ID. That's why my name is not visible. That's why.
Okay.
Thank you.
I see. As we are already running quite late, I'll request if anyone has any other doubts to reach out to us via mail or our Facebook page. And sir has also provided his mail ID. You can maybe reach out to him as well. And following that, following that,
you put your
yeah. And following that, I'll like to thank you, sir, for enlightening all of us, the machine learning enthusiasts here, in such an organized fashion and keeping it interesting simultaneously. We now understand the solution of business problems in machine learning in a more profound manner. You've made this evening tremendously fruitful for all of us, and we look forward to holding the hackathons and the participation from all of you here.
Thank you. I also enjoyed this session, and I hope to receive many submissions. So don't get bothered if you are not able to identify any particular machine learning algorithm which will just suit this problem as it is. I mean, just try to think even simple algorithms may work well here. So do try. Thank you all. Thanks. Bye then.
Yes. Thank you, sir. Bye.
Thank you so much, sir, for the session. I think he left the meeting. Thanks for the session, guys. Have a good night.